So now that we've reviewed listing common factors to find greatest common factor, I'm going to show you a new, exciting, awesome method that I like to call the birthday cake method. And at the end of this video, you can even ask to wear the birthday cake hat. That's right, I have a hat. Okay, so the birthday cake method is a different way that we can use to find greatest common factor. As we work through the unit, you'll also use this method to simplify fractions and to find least common multiple. So once you get used to it, you can use it to find a lot of different things. And once you get some practice with it, it will become a lot faster than actually listing out all the factors. In summary, it is awesome. So let's go ahead and try one together. So go ahead and move to your first box there. And don't forget to pause the video whenever you need to copy this down in your notes. Let's say you were asked to find the greatest common factor of 8 and 24. Remember, we could do this by listing the factors for 8, listing the factors for 24, circling common factors, and then finding the biggest factor they had in common. Here's how you do it with the birthday cake method. Write 8 and 24 next to each other, and we're going to draw what kind of looks like an upside down division sign. This is where I get the wording of the cake from, because as we draw more layers, you'll see it's kind of like the layers of a cake. Now that you have it set up, all you need to do is ask yourself, what can you divide into 8 and 24? And you have to think of a number that goes into 8 and 24 evenly, meaning there's no remainder. You may be thinking of a couple different options. 8 and 24 are both divisible by 2, they're both divisible by 4, and they're actually both divisible by 8. For the purposes of our example, we're going to start by dividing by 2. But later on we'll discuss how you can start many different ways and still end up with the same final answer. So since we're going to divide by 2, we're going to write the 2 off to the side there on the left-hand side. Then we're simply going to divide each number by 2. 8 divided by 2 gets us 4, so the 4 goes right underneath the 8. 24 divided by 2 is, that's right, 12, so we're going to put the 12 underneath the 24. Now look at the bottom layer of your cake with 4 and 12. Ask yourself, is there anything that we can divide into 4 and 12? Aha! Once again, we have a couple different options here. We could divide by 2 or 4. So we're going to draw another layer and keep dividing. We're going to divide by 2 again. 4 divided by 2 is 2, and 12 divided by 2 is 6. Once again, look at your bottom layer and ask yourself again, what can go into 2 and 6? Aha! Hopefully you said we can divide both of those numbers by 2. So once again, make another layer, and we're going to divide by 2 again. 2 divided by 2 is 1, and 6 divided by 2 is 3. Now looking at our bottom layer, with 1 and 3, you might have some trouble finding a factor that we can divide into both 1 and 3. There's actually only one number that goes into both 1 and 3. That's right, it's the number 1. When you get a bottom layer where both numbers are only evenly divisible by 1, then you can stop dividing. But you're probably saying to yourself, but we still haven't found the GCF. Once you're able to stop dividing, there's one last step. We're going to scoop up all our numbers on the side here. And since this is a birthday cake, we need some sprinkles. Or the official math term is multiplication signs. And then we simply multiply all of those numbers on the side together. 2 times 2 is 4, and 4 times 2 is 8. So we can say that the greatest common factor of 8 and 24 is 8. And that is the birthday cake method. Let's try another one together. Let's say you were asked to find the greatest common factor of 6 and 27. Once again, we're going to write these numbers side by side with our upside down division sign. And now ask yourself, what can you divide into 6 and 27? This one is a little tough, but hopefully you came up with a common factor of 3. 6 divided by 3 is 2. Remember, we write the 2 right under that 6. 27 divided by 3 is 9. Now looking at our bottom layer, we've got 2 and 9. Well, the only thing we can divide evenly into both 2 and 9 is 1. So we stop dividing and scoop up our numbers on the side. Now in this case, we only have one number on the side. So what do? You guessed it, that number then is just our GCF, or our greatest common factor. Let's go ahead now and move on to the next page and do some more examples together. Let's say you were asked to find the GCF of, let's do 4 and 40. Once again, we're going to set these up in our birthday cake and draw your upside down division sign. When we ask ourselves what we can divide into 4 and 40, you might be thinking a couple different things. We could divide these numbers by 2, or we could divide them by 4. Either way will get you the right answer. We're going to start by dividing by 2 first, and then in our next example box, we'll divide by 4, so we can see that it's the same answer either way. So if we start by dividing by 2, remember we write that number off to the side and then simply divide. 4 divided by 2 is 2, and 40 divided by 2 is 20. Looking at that bottom layer, we can see that we can divide 2 and 20 by 2. So we're going to draw another layer and keep dividing. 2 divided by 2 is 1, and 20 divided by 2 is 10. Now looking at our bottom layer, we can see that nothing will go into 1 and 10 other than 1. So at this point, we can stop dividing. And remember, we have one last step. That's right, scoop up those numbers on the side, add your sprinkles if you need to. 2 times 2 tells us that the greatest common factor of 4 and 40 is 4. Now let's find the GCF of 4 and 40 with the birthday cake. And we're going to start by dividing by 4. So once again, set up your birthday cake for 4 and 40. If we start by dividing by 4, we can see 4 divided by 4 is 1, and 40 divided by 4 is 10. Our bottom layer is now 1 and 10. Nothing goes into 1 and 10 other than 1, so remember at this point we stop dividing, scoop up those numbers on the side. In this case we only have 1, so once again we find that the greatest common factor of 4 and 40 is 4. And if we go back to our original example, we can see that even though we used 2 different ways to solve this problem, we ended up with the same final answer. Let's try another one. Let's say you were asked to find the greatest common factor of 5 and 11. Let's set those numbers up in our birthday cake. Draw your upside down division sign, and now ask yourself, what can you divide into 5 and 11? You might have trouble finding a common factor, and that's okay, because in this case, there's actually only one factor they have in common. Can you guess which one it is? That's right, the only common factor that 5 and 11 have is the number 1. If you can't find any other factors to divide by 5 and 11, you can then say that the GCF, or greatest common factor, is simply 1. Remember, this only works if nothing else can go into both of the numbers evenly. So you really have to make sure you're thinking of all of the different factors. Let's try one more together. Let's say you were asked to find the greatest common factor of 18 and 30. I would like you to pause the video at this point, try this problem on your own first in GoodNotes, and then come back to the video to see if you did it correctly. Remember, there's nothing wrong if you made a mistake. Mistakes are how we learn. I just want you to give it a try first before we go over it together. Okay, so you must be ready to check your work now. Double check to make sure you wrote the numbers side by side with the upside down division sign. Now, your work might look a little different than mine. Remember, there's more than one way that you can solve these problems, but in the end, we should have the same final answer. If you have a different answer than me at the end of this, please come and see me so that I can help you and make sure you understand what to do. One number that goes evenly into 18 and 30 is 2. I'm going to start there. Remember, you might have started differently, and that's okay. 18 divided by 2 is 9, and 30 divided by 2 is 15. I can then see that 9 and 15 are both divisible by 3, so I'm going to draw another layer and keep dividing. 9 divided by 3 is 3, and 15 divided by 3 is 5. My bottom layer now consists of 3 and 5, and nothing goes into that bottom layer except for the number 1. So that means, that's right, we can stop dividing, scoop up our numbers on the side, and add our sprinkles. 2 times 3 gives us a greatest common factor of 6. So even if you work this problem out slightly differently, you should have arrived at the same final answer that I did, that the greatest common factor of 18 and 30 is 6. If you had a different final answer, go back into GoodNotes and double check your work. If you're still confused at that point, please don't be afraid to ask for help. This concludes the video lesson for GCF. You're now ready to start your first practice problems.